Welcome back to our next installment of Chapter 4, Part 3. In this lesson we'll be selecting a power supply. Well, now that you've got a basic understanding of electricity, you're ready to take a closer look at the features of a power supply and how to select one. A power supply, also known as a power supply unit or PSU, is a box inside a computer, much like the one you see behind me, that supplies power to the motherboard and other installed devices. Now recall that a power supply serves as both a rectifier and a transformer to convert AC house current to DC and to step down the voltage from 110 or 220 to 3.5, 5 or 12 volts. Let's now turn our attention to the power features of a power supply, the types and characteristics of a power supply. And as you select the right power supply for the system, you need to be aware of the following power supply features. Feature 1, the form factor of a power supply determines the size of the power supply and the placement of screw holes used to anchor the power supply to the case, as you can see behind me. Now, in feature 2, we consider the type and number of power cables and connectors the unit provides. Connector types are shown in the table behind me. If a power supply doesn't have the connector you need, it's likely that you can use an adapter to convert one connector to another. And to find an adapter, just search for a site on the web, like at cables2go.com. They sell computer parts and cables. For example, if your power supply doesn't have a 12-volt 6-pin connector for your PCIe card, then you can buy an inexpensive adapter to convert two MOLES cables to this type. A power supply might have a voltage selector switch in the back. For example, the voltage selector switch on the power supply in the figure behind me can be set to 230 or 115 volts. When in the United States, set the switch to 115 volts and be sure to never change the switch setting until you first turn off and unplug the power supply. Now let's take a look at some of the common connectors you'll find in the power supplies. First one here up top is the P1 20+4 pin connector in the main motherboard power connector. Next, the P1 20+4 pin connector with the 4 pins removed so the connector can fit into a 20-pin motherboard connector. Next, the 4-pin 12-volt auxiliary motherboard connector used for extra power to the processor. Next, we have the 8-pin 12-volt auxiliary motherboard connector used for extra power to the processor, providing more power than the older 4-pin auxiliary connector. Next, the one that is kind of fading its way out of existence due to the growing popularity of SATA is the MOLEX 4-pin connector. It's used for IDE drives. Next, we'd like to turn your attention to the SATA connector, used for SATA drives. Next, the floppy drive connector, hardly used anymore. And then next, the 6-pin plus 2-pin plus with positive 12-volt connectors used on high-end video cards for PCI 16 slots and so on. PCI Express version 1 also uses a 6-pin connector, and the PCI Express version 2 uses the 8-pin connector. To get the 8-pin connector, combine both the 6-pin and the 2-pin connector. Feature 4 I want to discuss is every power supply has a fan inside its case. Some have two. The fan can be mounted on the back or the top of the PSU. They range in size from 8mm to 120mm. 5. A power supply might have an on-off switch that controls power to the system. The power supply has wattage ratings, which are the amounts of power it can supply. These capacities are listed in documentation and on the side of the power supply, as shown here behind me. Now, when selecting a power supply, pay particular attention to the capacity for the 12-volt rail. A rail is a term used to describe each voltage line of the power supply. The positive 12-volt rail is the most used, especially in high-end gaming systems. Sometimes you need to use a power supply with a higher end or higher than needed average. Feature 7, consider the warranty of the power supply and the overall quality. Some come in bright colors and the cables might be of higher quality than others. The more expensive power supplies are quieter, last longer, and don't put off as much heat as less expensive ones. Also, expect a good power supply to protect the system against other voltage. So, which power supply is right for you? Well, when selecting a power supply, match the form factor so that used by the case and the motherboard, and make sure it provides the connectors that you need, and match the wattage capacity to the requirements of the system. In addition, consider the warranty price and the additional features you learned about in the previous selection. When deciding what wattage capacity you need for the power supply, consider the total wattage requirements of all components inside the case as well as USB and FireWire devices that get their power from ports connected to the motherboard. Keep these points in mind when selecting the correct wattage capacity for a power supply. Point 1. A power supply produces slightly higher wattage at room temperature than it does when the temperature inside the case has been risen above the room temperature, called the operating temperature. Therefore, a power supply might have two ratings, one wattage rating for room temperature called the peak rating, and another rating for continuous operation at operating temperatures, sometimes called the actual rating. Now, if a power supply has only one rating, assume that the rating is the peak rating for room temperature. To calculate the rating for continuous operation, deduct about 10 to 15% off the peak rating. For example, the Silencer 610 power supply by PC Power and Cooling is rated at 610 watts at operating temperature and continuous operation, but has a peak rating of 670. Point 2. Video cards draw the most power in a system, and they draw from the positive 12 volt output. So pay particular attention to this rating. For example, as you see behind me, you can see that the positive 12 volt output is 300. Notice in the figure the unit is rated at total peak load of 450. Use a power supply that is rated about 30% higher than you expect a system will use. Power supplies run less than peak performance and last longer and don't overheat. In addition, a power supply loses some of its capacity over time. Don't worry about the higher rated power supply using too much electricity. Components only draw what they need. To know what size power supply you need, add up the wattage requirements of all the components and then add 30%. Device technical documentation might give you some more information about this. Point 4. The websites of some power supply and motherboard manufacturers have a wattage calculator where you can enter the components in your system, and then the calculator will recommend the wattage that you need. You will see, for one example of the wattage calculator in Project 4.7 at the end of the chapter. Here are the wattage needs of 4 typical systems. A regular desktop system with a moderately priced motherboard using an LGA 775 socket for Intel or an AMD 2 socket for AMD. One moderately priced video card, 2 SATA hard drives, a DVD RW drive, 2 fans, needs a power supply rated about 300 to 350. Example 2, a desktop system used as a file server with a high-end motherboard, Intel or AMD, moderately priced video card, 6 SATA drives, DVD and tape drive, PCI RAID card, and 4 fans, needs a power supply rated about 550. A gaming system with a high-end motherboard using an LGA 775 Intel processor and AMD socket, 2 high-end video cards, 2 SATA hard drives, Blu-ray drive, 4 fans, needs a power supply rated about 800 watts. The 2 high-end video cards require 275 watts each. If a liquid cooling system is used by gamers for overclocking the system, and if that's installed in the game system, that's the one we talked about before, the power supply wattage should be increased to about 1,000 watts. Overclocking is running a processor, motherboard, or video card at a higher frequency than the manufacturer recommends, and is not considered best practice. It might also void the warranty of a component. Point 5. The Dell ATX power supplies and motherboards might not use the standard P1 pinouts for ATX, although the power connectors look the same. For this reason, never use a Dell power supply with a non-Dell motherboard or a Dell motherboard with a non-Dell power supply without first verifying the power connector pinouts match. Otherwise, you might destroy the power supply, the motherboard, or both. NPC Noise sells a pinout converter to convert the connector of a Dell power supply or motherboard to a standard ATX. Also, PC Power and Cooling. PC Power and Cooling makes power supplies modified to work with a Dell motherboard. Now, that's all I'm going to talk about today for choosing the power supply itself, or covering that power supply. And then do any lessons that we've got set up in the school management system. Come on back, and we'll get on to the next chapter, part 4. See you.